All right. So we are going to be doing things a little bit differently in math intervention this week compared to normal. We're going to be actually learning some new things in math intervention, and we're going to do it through video notes, and then you're going to work on some practice yourself. So it's going to be a little bit different setup than normal. So you should have a paper that looks like this to go along with me as we do our notes. This one is all about the area of parallelograms. To review a little bit, the area of a rectangle or square that we learned years ago is length times width, or base times height. So this little rectangle I drew right here, we have a base of 3, or a width of 3, and a height of 2, or a length of 2. So to find the area of this little rectangle is just going to be length times width. So area equals 3 times 2. Well, that's an easy mental math fact. We know that 3 times 2 is 6. So our area for this rectangle is going to be 6. All right, so as we continue on, we're going to start talking about parallelograms. Parallelograms are shapes with 4 sides, so they're quadrilaterals with 2 sets of parallel lines. Now, the weird thing about parallelograms is that usually one set of the sides is diagonal or slanted. And I want to show you something a little interesting. So when you're looking at a parallelogram, just like this black shape here that I made, if you want to understand why the area is also length times width or base times height, is simply if we cut off one of our sides of our parallelogram, so we cut off a side, and then we drag it up onto the other side of our parallelogram, it creates a rectangle. So therefore, our area of a parallelogram is going to be the same as an area of a rectangle or a square. And remember, area is the space inside of the figure, not the perimeter, which is around. Okay, so area is the space inside of a figure. Oops. All right, so we're going to take a little bit of notes together. So like I've said a couple times, the area of a parallelogram is the product, or when you multiply the base, which will be b, and height, which will be h. We are going to be using variables for this little unit, such as b for base, h for height. We'll be using those pretty often. So they give us our formula, which is a equals b times h, or base times height. When you take your state tests or any other formal testing on this, they're not going to give you the formula. Area equals base times height is something you just have to memorize. You just have to truly memorize it, have it stick in your brain, okay? So we have example number 1. Find the area of the parallelogram. They give us our formula, which is rare, but it's an example. So we have area equals base times height. Okay, so first thing we got to do is figure out what is base and what is height. Well, if we're looking at our parallelogram, you always want to use it's kind of hard to see on here. Your base is the bottom line. So it has 1, 2, 3, 4. Your base is 4 in length, 4 squares. And your height, when looking for height of a parallelogram, you're going to be looking for a straight up and down height. You are not ever going to use the diagonals. Never, ever are you using the diagonals, okay? You're looking for a straight up and down height. You want it to be perpendicular with the base, or that just means has a right angle. See that little square right there? That notates a right angle of 90 degrees. So let's count the height of our parallelogram. 1, 2, 3, 4, 5, 6, 7. So base is 4, height is h. Now all we do is take those values and plug them into our formula. So we're going to have area equals our base of 4 times our height of 7. Then we go ahead and solve. Area equals 4 times 7, that's 28. Because it's area, we got to get back in the sense of having units. So we're going to label this one 28 units squared. That's just how we notate area. All right, example 2. Find the height of a parallelogram. This time they don't give us the height of our parallelogram. They give us our base, which is 6. And notice they drew the 6 on top of the parallelogram instead of at the bottom here. It doesn't matter. They are the same length. If they're parallel sides in a parallelogram, they are the same length. So we can figure out what we know. Well, we know that B is 6, base is 6. We don't know what our height is. Height is that missing variable value we'll have to solve. But we do know that our area is 24. Now we can just plug everything that we know back into our formula. We know A is 24. We know B is 6, but we don't know height. Guess what we have here? An equation we get to solve using inverse operations. If we have 6 times h, well, we want to get h by itself. So we're going to go ahead and do our inverse of times 6. What's the opposite of times 6? Divide by 6. Just like with equations, we're going to do it to both sides. Our 6's cancel out. 24 divided by 6 is 4 equals h. So our height is 4 inches. I got inches because our area is in inches squared. Therefore, we know that our unit is inches. All right, we'll do a couple more. Find the area of each parallelogram. So first one, notice it doesn't give us our formula, so you have to just memorize it. Area equals base times height. So we're going to first label what we know. Do we know our base? Well, let's see. It's going to be 1, 2, 3, 4. Do we know our height? Remember, it is not diagonal. Do not use the diagonals. The height is the straight up and down. 1, 2. All right, plug in what we know. Area equals, it's a wonky, 4 times 2. Our area equals 8 units squared. Okay. All right, we'll do 2 more quick ones together. Sometimes our parallelogram is labeled out like on number 2, how they don't give you the height inside of the parallelogram, how normally we've been seeing it looks kind of like this. They give you your height on the outside. It's the same thing. So we know our base is 18 centimeters around here. Our height we know to be 35. And our formula is area equals base times height. All right, plug in what we know. We know B is 18 and height is 35. I'm going to go ahead and grab out a calculator for this one. You could do the long multiplication, but our area is 630 centimeters squared. All right, one more together, and then you have an entire page of practice that I want you to go ahead and work on today. All right, so our last parallelogram is one that has decimals. Decimals and fractions do not change the process. We know how to use decimals. We know how to multiply with fractions. So we know our formula is area equals base times height. We know our base is 8.8 down here. We know our height is 10.4. Remember, we're not using diagonals. It's the straight up and down one. All right, so now we're just going to go ahead and multiply. Area equals 8.8 times 10.4. Again, you could solve it out using your area model, or you can use a calculator if it is provided. 91.52 meters squared. All right, so during this math intervention block, I want you to finish the rest of this page provided. Number 5, you're going to have to put your mixed numbers into improper fractions to multiply. So real quick, an example of how to do that. If we have 5 1/3, you're going to go ahead and multiply your denominator and your whole number. So 3 times 5 is 15. Then you're going to go ahead and add your numerator. 15 plus 1 is 16. So you're going to have 16 over 3 as your height of this parallelogram. You'll do the same for your base, and then you'll multiply out. Remember, multiplying fractions, you go straight across. For number 7 and 8, it is much more of a challenge, and I understand if you don't finish these ones. You actually have to find the area of both the outer quadrilateral and the inner. So you have to find your area of your shaded in quadrilateral, then you have to go ahead and find your area of the smaller quadrilateral and subtract to get your area of just the shaded. These are the ones that Dr. Ivanhoff will be around to definitely help you with if you need. It might not be shaded very well on your paper, but in case, these are them. All right. So you can rewatch this video as many times as you need to take notes to solve out, but I do expect you to be able to get some of these parallelograms done before the end of your class. Good luck.